So in the second part of the video we will like to discuss the actual project demo, and we will see how it is actually working. So the first thing I would like to show you is, you can see on the left side of the window there are a bunch of folders which are actually the same name as you have already seen in the part 1. These are with the same name as their controllers and modules. So let me show you one of their modules and how we actually did testing for that. So one of the module that I'm actually trying to open is compute unit. So this compute unit is actually have some kind of parallelism. It actually calls the some number of copies of DPU, and we actually have the result of from that DPU module in a single cycle. So it was added to have some kind of better performance, and the parallelism concept is actually added in this module. So the idea behind the testing is, we actually create the input data in Python, and we generate the results in Python also, and we actually implement the same functionality as per their modules have implemented, and we generate the results from both uh, like from their hardware and from our Python scripts, and later we compare those results and try to see if they match or not. If they match, that means their functionality is accurately fine and everything is working fine. And if there has some kind of issue, we actually try to report that, and or if that is like fixable on our side, we actually try to fix that and do the testing again and verify that and report that again. So this was all about the MATML. So now we will like to discuss about the convolution. That is kind of our thing, and we can discuss it openly with you. So the convolution is actually the simple process. We have the matrix, we have the kernel, and we actually perform a bunch of matrix multiplication inside it and move our kernel over the matrix. And like the maths, we have already know what the maths behind this convolution is. So now I will directly move for the demo. So I've quickly moved for the demo, and first of all, you can see on the left side there are a bunch of controllers and some modules. So these are same as we have already discussed in the part 1 of the video. There is some controller and matrix compute unit, and there are accumulator units that are actually doing some smaller computation. So in order to check that, we actually just have to run this program, and for that let me just run it real quick. So there are two parts. First of all, it will try to generate the results, and second part, it will also try to compare the results from that Python's script that we have written and we have already input into this project. Like we have already set up the project. Just to save the time, we have to run it for all. And if you look closely, there are some results over here. It says there are total values like these, and it actually got zero wrong count, which means that our Python script results are exactly matching with this hardware convolution result, which means that our hardware module is written very fine and it is working accurately. So the next thing we also want to discuss is the efficiency. We just have to note this number, so we will be using this later here. So now I'm going to run this project, which is actually doing the same thing. It's using the same input file, and it will generate the results, and we will actually note the time, and we will see which program is faster and how much is that actually faster. So I have run the process, and it says it actually took 0.09300 seconds, and it actually asking for the execution time of the first program, and there we actually have copied that already. We can just paste it over here, and I'll hit enter, and it actually shows us some numbers. And if you look closely, it actually says program 1 that we actually entered over here is 99% faster uh, than this Python program. So we can understand how fast the hardware design is. So there is some kind of limitation in this comparison, like we should also have to uh, encounter the clock rate and the synthesize modules clock rate. Like there are bunch of things that we have to encounter in order to accurately compare these results, but as a whole, as a understanding, we can just have the idea of it, like uh, if that actually matters, like the clock rate and everything, even that matters, and that actually decrease this efficiency, we can still imagine how fast the hardware design is that we have just generated. So this was all about our project. I hope this makes things uh, clear, and if you have some kind of confusion, you can read our detailed documentation over GitHub, and you can also read our report that is attached with this video. Thank you so much.